As you can see on the screen, our very flexible platform for integration, collection, and analysis of social media for open data provider in smart cities. We would like to present a summary of the result that we have accomplished in the paper. In this paper, we build tools and solutions to enable developers to build systems that collect and analyze different types of data from social media with aim to supporting open data providers in smart cities. Paper will be illustrations of 4 case studies. First, we illustrate the video analysis by taking data from CNN, CBS for more than 1 month with over 200 videos to analyze and evaluate the news released by each celebrity. In addition, we monitor the advertising information of brands based on logo analysis. We also build systems that have 5 starting time and footprint maps based on sound analysis. And finally, the traditional data form of social listening tech advocacy used for the analysis for enrollment information based in recent time. The main content of this paper is presented in 5 parts, which focus on solution, construction system, as well as results are presented in section 2, 3, and 4. In recent times, more and more information is being generated in various forms such as images, sounds, videos, articles on social media around the world. And with such rapid development, the amount of data is very large. The formats are also diverse and rich. The need to analyze, listen, and decode important content or events from social media is one of these essential needs. That's why in recent times around the world, as well as in Vietnam, social listening application to listen, collect, and analyze important issues related to the reputation, status of individual or brand is one of the concerned topics with many rather developed and applied. In Vietnam, systems such as Revuta and Social Hit are also developed and implemented, providing service to analyze social media data, mainly analysis on data in natural language like text. If social media listening solutions can be applied in many different formats, not only text but also analyze information from images, videos, and audios, they will provide more valuable resources for analyzing social change as well as finding important events relevant to individual or the organization. Therefore, within the scope of the paper, we aim to be able to listen, collect, and analyze with many different data formats in social media, not only text but also images, videos, and sounds. We also try to have obtain data from various public sources, such as YouTube and social networking sites, and also allow to access, manage, and share databases such as decentralized on-cloud online systems. In addition, the need to analyze different types of information with different intelligent processing algorithms will also be flexibly integrated so that object detection, face recognition, or finding important content from video sound. The goal of our paper is not to build a specific application, but to learn and propose tools, software architecture, processes, and solutions to create a flexible platform. From there, it is possible to assemble quickly and efficiently into different applications, depending on actual needs, with an easy-to-expand architecture, integrating with many algorithms, or can train different AI models and is compatible with many types of data from many different sources. And on that platform, we have built 4 illustrative applications we show in the first part. Using the tools and solutions that we built in the paper, we try to develop illustrative 4 applications to see if our tool and solution are flexible enough and integrate with each other to quickly create different applications or not. For example, we do video analysis from CNN channel so that we can show the news through analyzing the human face or finding exciting moments in board games based on sound analysis of the game. Specifically, for the application related to human face recognition on news video. The application has collected more than 200 news videos in 1 month from YouTube channel. CNN, CBS News, training data of 30 famous faces that Donald Trump and Joe Biden to recognize human face on collected video, then visualize the news about that character on the world map. In addition, there are new trends about famous characters on stream rap track over time. The architecture of the application includes building tools to support features such as collecting data, providing interactive statistics and information, as well as facial analysis. The problems both when building the system architecture are data can have many types of formats, so solution build must be able to support the processing and storage that is appropriate for each data format. We use MongoDB to store text data and Google Drive to store image data, videos, for data from many sources such as social networks like Facebook, YouTube, or cloud storage like Google Drive. We also build tools to collect data from multiple sources on the internet. Based on a distributed architecture using a salary type queue management system, we will define ways to collect data from Facebook, YouTube, WinExpress through API library into salary tasks. Every day, through the salary client send tasks to RabbitMQ to distributed tasks to worker performing data collection. Our goal for illustrative applications is to use same set of tools and processes, flexibly apply different algorithms to analyze many different formats of data. Therefore, the tool of data analysis must be able to replace and integrate different algorithms when the need arises. Above is a process used to analyze multimedia data such as images, audios, or videos. These data stored in Google Drive will be retrieved to be used as input for an AI algorithm models or functions, depending on the specific application and specific needs. As a result, the above data will be stored back into Google Drive, ready for analysis when needed. Here, we would like to introduce the application that allow analyzing the content of posts on social networks. This application allows to collect data on Facebook fanpage posts of universities, such as University of Science or Macquarie University, from the collected data, statistics of interaction as well as number of message time university, support to graph enrollment situation of university. Besides, the application also supports the display of new collected from being spread. This application uses the traditional form of data with the text. So the architecture had a change in the stroke of data collected and the storage system as well as the data analysis solution compared to the first illustrated application. The logic used to analyze textual data is quite similar to the logic of analyzing multimedia data. However, there are some differences like text data should be stored in MongoDB, and the start data analysis function and model are also related to be adapted to textual data. Based on the two data analysis process mentioned above, we propose a generality rosette with the main processing section flexibly applying function or algorithm depending on needs. Besides, use storage system suitable for a data format. We also would like to present to you the third application to support product and brand identification. Specifically, the application uses the object detection model to have track compact energy ring in the video of the brand Vietnam, then show the distribution of the product logo as on the facet chart. The application also supports visualizing the appearance of the product logo through a video frame. In addition, the application allows a manual upload to have identified object in the image. An important feature of AI model application includes model training support, and depending on specific needs, we will need to train new model. The architecture of this app is similar to that of the first news video app. The change comes from data structure as well as the data analysis algorithm used in object detection. I would like to introduce the Rosetta building a new artificial intelligence model. The programmer's job is to provide datasets for training the model according to needs. After training, the new model will be deployed into APIs to use for data analysis. For analysis browser on the image, we will provide the direct link of the image and train analysis algorithm model on the image. Similar to analysis on image, the only difference of analysis on video is that the video will be cut into multiple images before using the analysis algorithm. We use the React player to visualize the video frame analysis algorithm. We also use the virtualized technique to solve the problem of loading the number of images in the video with high duration. Coming to the last app. This is the app that illustrates the audio analytical aspect of video. Application that collect football video from FIFA TV channel based on the intensity of the sound at the time in the video of football. The app allows to summarize the exciting development of the match. We can also observe the statistics related to the audio intensity in the video via the area check. Besides, the application also provides a flexible statistical interface drag and drop and change the position of the track. The architecture of this app is similar to that of the first new video app. The change comes from the stroke of data and the FIFA TV channel, as well as the function that allow cutting out exciting moments of video based on the intensity of the sound, as well as analysis process on video. The change here uses an algorithm that summarizes how exciting a football match is based on the intensity of the sound. After presenting technical solution, as well as illustrate the application, we would like to raise the question that a system can have a specific feature depending on usage need. So, how to integrate feature when needed? We propose the general architecture of the system, which is also used throughout the 4 case study. The general architecture consists of 5 components, serving different requirements and features. In this paper, we develop a flexible platform to support the creation of systems to collect and analyze social media data. We provide components and utilities that are used to quickly generate open data providers based on different social media sources. We would like to present the result achieved throughout the above numbers. Showing what we have done in the paper, we can be mentioned as handling 2 data sources, data from the internet and private data provided. Support 4 types of data format: text, audio, image, and video. Learn and use 5 data analysis solutions such as object detection, human face recognition, etc. Then, based on 5 tool build and 6 technique learn, deploy 4 tech applications. The tool had actually deployed on 2 platforms, Google Colab and VBS. So, Spark City needs open data provider. Since open data provider need to be supported quickly, the input as social media, so we need to develop the flexible platform. We experimented with many text, image, video, including analysis by application related to vision, sound, even NLP. Furthermore, as is especially important what we make several systems to demo specific case for supporting open data provider in smart cities. We will continue to explore technology solutions to develop and perfect the data collection and analysis system with increasingly diversified and effectively intelligent zero-sex features that improve system performance, extend the system distributed data storage capabilities, improve and add more intelligent processing features to serve the different needs of users, edit more lively and attractive tracks. Our presentation here is the end. Thank you for watching.